We could approach this a couple different ways. We could approach this as we're looking at integration, which is essentially the sort of the inverse of finding the derivative of differentiation. When we looked at finding the derivative of something and what the derivative was, we first looked at what it meant in terms of a graph. It's the slope of the tangent. And then after that, we started to look at rules for differentiation, the product rule and chain rule and all that sort of stuff. We're taking a slightly different approach here, and we're looking at kind of in an abstract way, we're looking at antiderivatives and how you can find things like that and some of the notation. And then later we're going to look at what it actually means in the situation. This is why we're not necessarily following the order of the book. The symbol for finding the derivative, you have a couple, d dx of some function, or you could say with the little tick mark, f prime of x. The symbol for the derivative, of the antiderivative, or in other words, we're going to talk about the integral of a function, is this elongated S shape like that. Okay? It does look like a smart symbol because anything you can't do just with the keyboard is, you must be smart, I think. You feel smarter using that symbol. Anytime there's like a cartoon or something where somebody's trying to look smart mathematically, they always have that symbol as one of the symbols, right? If they're just kind of having a bunch of random math written somewhere, they always have that. This is the integral symbol. It has to do with kind of the sum of something, which we will see later on, how it's connected with the sum of something. For now, you can just learn that that's the integral. So if you're writing the integral of, or in other words, the antiderivative, well, the antiderivative, the integral is the set of all antiderivatives. If you say what's an antiderivative of 2x, you could say it's x squared, you could say it's x squared plus 1, or anything, right? Any constant. If you say what's the integral of 2x with respect to x, this part is saying x is the variable here. It's the same as why it says dx here. When you find the derivative of a function with respect to x, you're saying x is the variable, because when you did the chain rule and stuff, you could do d dy of something, d dx, d dt of something. It depends what the variable is. If you write this, you're saying, what is the integral of this function with respect to x? I guess I should make it color coordinated with everything else. Okay, with respect to x. That's a C, thank you. With respect to x. Okay, with respect to x. That's what this dx on the end here, it's just the same as this dx under here. At first you said, well, I don't know, what is this dx underneath here? It's just part of this symbol saying you're finding the way we looked at this was you're finding the derivative of this function with respect to x. It's the same thing here. You're finding the integral of this function with respect to x. So that's what we have written out down here. The integral of, and you can try some of these here, the integral of x to the fourth, and this might be hard to start seeing this, the integral of x to the fourth with respect to x is 1/5 x to the fifth plus a constant. If you're asked to find the integral, you need to include this because you're saying the integral is the set of all antiderivatives. Do you have to put the what? Nope. No, because we're not actually evaluating it yet. Let me show you the difference here. We'll have a preview of what's to come this month in Calculus 12. You know those commercials where they show for a channel? This month we're showing all of these things. This is what's to come here. We need a new page. This is important enough that we need a new page here. When we learned derivatives, we looked at, somebody could say, what's the derivative of x to the third? Right? Or they could say, the other way you could say this is, you could say, if f of x equals x to the third, what's f prime of x? They could also ask you, what's f prime at 3? Like a specific value. This is in general, what's the derivative? And this is specifically, what's the derivative at that value? What's the difference in your answer for those two things? F prime of x is going to be, yeah, just 3x squared, but f prime of 3 is going to be whatever, yeah, 27, right? Whatever 3x squared is. This is a number. It represents something, something definite in this situation. If you have the x to the third curve and you want to know what it is, it's the slope at that point. This is the slope anywhere on the curve. This is the slope at a specific curve. This is kind of indefinite. This is definite because it's a specific number. Not that you use these two words with derivatives, but you do use those two words with integrals. So for now, we're going to have what's the integral of, and I guess I should put the word integration here. Integration. Okay, when we find if you have some kind of a function here, you can talk about if we have x squared, you could talk about the integral of x squared with respect to x. What was that again? What would that be? Integral of x squared? 1/3 x plus a constant. X cubed over 3. 1/3 x cubed. Later on, we're going to look at what is the integral of this function, but evaluated for specific values. So we're going to say, now the problem is you don't evaluate this for one specific value. You evaluate it from a certain number to another number. So we're going to put numbers on there. What? This is going to be called the definite integral.
That's in the notes.
This is going to be called the indefinite integral.
That's far ahead, though, isn't
It
it?
is, yeah.
That's like halfway.
Okay.
That's section.
When you're making the decision on what to teach first here, I'm torn always because when you look at this, it's abstract. It's not related to anything in a real situation, but I think it's easier for you, even though it's completely abstract at this point. When you have the connection with real world things and you can actually talk about it in a real situation, but it's more difficult conceptually, I think. Usually it's better to start with the thing that's involved in a real situation and then move to the abstract. But in this situation, I've made this decision because this one tends to be easier.
What is the
Okay?
answer for the definite?
Well, we need a whole bunch of background here, but you're going to use this. You're basically going to evaluate that at 3 and evaluate it at 2 and subtract it, but we have no clue why we're doing that at this point. Okay?
I do.
You don't have to understand why, you just have to do it, right? This first thing is just finding indefinite integrals, which is just finding antiderivatives and putting plus c on the end, right? Can you work through the rest of the ones in there? I tend to have put kind of way too many questions probably in here. Let's see how many questions I put. Lots.
You got the answers right here, eh?
The answer's at the end. I tend to not like formulas to memorize, but if you want, so this is why I worded it like this, if you want to write formulas, you can write down formulas. You've already written one for integral of x to the n, right? What did you write? You wrote 1 over n plus 1, x to the n plus 1, but you have to put a plus constant on the end. This is if you have a constant times a function. Just the same way as if you had the derivative of 3 times f of x, you could write it as 3, you could pull the 3 outside, right? If you're finding the derivative of something, you pull the 3 outside. You can do the same thing here. If you're finding the integral of a constant times a function, you can pull the constant outside. Does that make sense? Okay, you can put the constant outside. These all parallel what you have for derivatives. If you want to know the integral of two functions added together. 10 minutes. Okay, I got to start talking faster. Well, if you sit there and panic, then we're never going to get it done. Like, listen, if you want the integral of two functions added together, it's just the integral of each one separately, right? It's the integral of f of x plus the integral of d of x. You already used that, g of x. You already used that before when you found those things. The integral of a constant, the integral of 3 is just 3x, right? And I have to stop even though I didn't write it over there.